Hello everyone, welcome back to Nunley Math. I'm Aaron Nunley. Thank you so much for joining me here today for the third video in our series of videos on the linear function. If you've been following along with us for some time, you know that we completed probably a 4 to 6 week unit in my class about functions in general, and then we said we were going to take 2 or 3 weeks and focus really in great detail on the linear function. In the last two videos, we've spent some time introducing two patterns to you that are very helpful for us when working with linear functions. The first video focused on the standard form of a linear function or linear equation, and then in our last video we introduced this idea of the slope-intercept form of a linear equation. And we're going to stick with that slope-intercept form a little bit more today. You'll see this one's called writing linear equations in slope-intercept form. So we're going to take some of the ideas that we introduced in our last video and we're just going to stretch those a little bit. Hopefully this is going to be a little bit shorter of a video because some of the information will already be familiar to us from the previous video, but it's certainly going to be very valuable in that it allows us to work with the slope-intercept form in a slightly different way. So let's go ahead and get started. We're going to dive right in. Notice the directions say give the equation of a line when given the slope and the y-intercept. In our previous video, we said that the slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. Knowing this pattern, it should be very easy to write the equation if they give us a slope and a y-intercept, because all we have to do is take the pattern that we know works, or the pattern that we call the slope-intercept form, and then just plug in the appropriate values. So if you say to me, suppose a line has a slope of -3, well, you've just told me what this number here is. And then it says, and a y-intercept of 1/2, then it says, what is the equation of the line? Well, we know the slope is -3. We know the y-intercept is 0, 1/2. So all I'm going to do is plug those numbers into this pattern right here. Y equals -3x plus 1/2. And I'm done. Pretty easy, right? Here's another example of that over here to the right. Give the equation of a line where the slope is 0 and the y-intercept is -2. Well, slope is 0. The y-intercept is the coordinate 0, -2. I'm just going to plug that into this y equals mx plus b pattern, and I get y equals 0x minus 2. Notice, of course, that 0 times anything just becomes a 0, so this is actually 0 minus 2, which would simplify to y equals -2. Notice, since my slope is a 0, in the previous video we said anytime that happens, you end up with a horizontal line for your graph. So this is actually a horizontal line that goes through -2 on the y-axis. Not bad, right? Tell you what, over in this example, we're going to do the same thing. It says give the equation of the line graphed below. They did not explicitly tell us the slope and the y-intercept, but we certainly can look at the picture here and we can find those two things very easily. Notice we have a dot at 0, -3, and we have a dot at 4, 3. Slope is defined as the rise compared to the run, or the amount of vertical change compared to the amount of horizontal change. In this example, we go up 1, 2, 3, 4, 5. We go up 6, and 1, 2, 3, 4, right 4. So my slope is 6/4, or I could simplify that to 3/2. Notice, if I start at this bottom point and go up 3/2, I do still end up at a point that is on this line. The y-intercept is given to us here, 0, -3. Once I have these two things, it's very easy for me to write my equation. My slope is 3/2, y equals 3/2 x minus 3 because of the -3. I've got one more here. I'd recommend you pause the video, try this one on your own. I'm going to go ahead and hop right in and show you, assuming that if you wanted to pause the video, you already have. I can see that I go down 1, 2, 3 when I go over 4, giving me a slope of 3/4. Notice since it is going down, it is going to be a -3/4. Positive slopes always go up left to right. Negative slopes always go down from left to right, so down 3/4. I can also look here and see my y-intercept is the coordinate 0, 2. In slope-intercept form, It's y equals negative 3/4 x plus 2. Here's one of the reasons why we like the slope-intercept form so much. Because if we get a graph, it's very easy to come up with the equation. If we have the equation, it's very easy to come up with the graph. What I do want to do today, though, is I want to stretch this just a little farther and show you some other ways you can find the equation of your line if you are not given the slope and the y-intercept. For example, this problem says write an equation for a line that passes through the point negative 3, 5 and the point 0, negative 1. Notice we do have the y-intercept, the 0, negative 1. What we don't have is the slope. But fortunately, we have a pattern that we know works for finding the slope. We know that the slope is the rise of our line compared to the run of our line, or how much we change vertically compared to how much we change horizontally. That is, the change in my y-coordinate tells me how far up and down I've moved. The change in my x-coordinate tells me how far right and left I've moved. Notice I've used the Greek letter d, or delta. Delta means change in mathematics. So I've got the change in y compared to the change in x, or over here on the far right, I'm going to see how far my y's moved compared to how far my x's moved. Notice I have this labeled as y2 and y1, x2 and x1. It does not matter which of these coordinates is x1, y1. What does matter is that if you use, for example, the negative 3 as x1, that's fine. You just need to make sure that y1 is paired with it. Notice the order matters. My y1s come second, my y2 and x2 comes first. My y1 and x1 are second, my y2 and x2 are first. This is x2, this is y2, and I just go through and plug in my numbers. This says take the negative 1, my y2, minus the 5, and take my 0, my x2, minus the negative 3. So I just plug in those numbers. Negative 1 minus 5 is negative 6. 0 minus negative 3 becomes plus positive 3, so I get a 3 on the bottom. My slope is negative 6 over 3, or in simplest form, my slope is a negative 2. Now, just for the sake of making sure that I'm abundantly clear, if I had made this x2 and had made this y2, and I had made, that's not very neat, this x1 and this y1, when I plugged in my numbers, I would have gotten 5 minus negative 1, and I would have gotten negative 3 minus 0, which would have given me on top a positive 6, and on bottom a negative 3, which is still a negative 2 for my slope. Again, it does not matter which one is x1 and y1 and which one's x2, y2. The important thing is that x1 and y1 are together and x2 and y2 are together as well. Now that you know your slope, we already have the y-intercept. It is written right here. You have your slope and your y-intercept, so you can write the equation of the line. Y equals m, your slope, x plus b. b is that negative 1. Remember, minus 1 and plus negative 1 are the same thing. I'm going to go ahead and erase the ink on the slide. I want you to come over here and try this one on your own. Pause the video while doing that, and then restart it to see if what I do matches what you do. I'm going to go ahead and assume you've already done that if you wanted to. I've done y2 minus y1 over x2 minus x1. I plug in the appropriate values. I put a negative 5 as y2, which means the 8 is x2, minus negative 5 as my y1, which makes a 0 my x1. I subtract those, and I get a slope of 0. Once I know the slope, the y-intercept is already given to me, so I can write the equation pretty quickly and easily. Notice again, with a slope of 0, 0 times anything is 0, so 0 minus 5 gives me the horizontal line y equals negative 5. The third example is very similar to this, except I've done it with function notation. Notice it tells us that f of 0 equals 10 and f of 6 equals 34. This just means if I put a 0 into my rule, then it's going to equal 10 when it comes out. So this is my input value. This is my outcome value. Or you would probably be more comfortable if I wrote that as the coordinate 0, 10. Notice here when I input a 6, what comes out is a 34. That makes this the coordinate 0, 34. And you can see that this is exactly like the other two examples. Notice you have the y-intercept, you have another point. All we've got to do is use the slope formula, y2 minus y1 over x2 minus x1 to calculate the slope, and we'll be finished. So if I take 0, 10 and 6, 34, didn't realize I had those in my slideshow, so I'm going to erase those. There we go. If I take my 0, 10 and my 6, 34, and I plug those into my slope formula, notice I made this x2, y2, made this x1, y1. You could have just as easily have switched that. You come up with 24 over 6, which gives you a slope of 4. Once you know the slope, the y-intercept is this 0, 10, meaning your function or your equation is y equals 4x plus 10. Now notice I wrote this in equation form because that's what we've been dealing with mostly. However, since it does say give the linear function, remember that y is the same as f of x. So I really should write this as f of x equals 4x plus 10. Remember, it means the exact same thing. I'm just being cautious or conscientious about the fact that they've asked me about functions and they've given the information in function form, so I want to be courteous and give my final answer in function form as well. One last example of this, I'd recommend pausing the video, trying this on your own, seeing if what you get matches what I get. I'm going to assume you've already done that, and I'm going to go ahead and keep moving forward. This is the coordinate 0, 4. 0 is my input, 4 is my output, and the coordinate 3, 8. 3 is my input, 8 is my output. I plug those into my slope formula. I get a slope of 4/3. My y-intercept is given to me. That is the coordinate 0, 4. And it makes it very easy to write the function. Notice as well, I should probably have given this in function form. F of x equals 4/3 x plus 4. Again, once you've got 2 points and one of them is the y-intercept, it's very easy to come up with the slope and the y-intercept and just plug them into the pattern. Here's one final example for you. Notice that this is a larger application problem, but it does use what we've been talking about with slope-intercept form. So I did want to make sure I mentioned it and got you used to kind of how you might see this in real life. This says, excluding hydropower. Hydropower is power generated when water passes through a dam to spin the turbines. U.S. power plants use renewable energy sources to generate 105 million megawatts of electricity in the year 2007. That seems important. I'm going to circle that so I don't lose track of it. By 2012, that seems important as well, the amount of electricity generated increased to 219 million megawatt hours. Notice there is a change. We went from 105 million in 2007 to 219 million in 2012. Write a linear model, so we're going to assume this grew at a constant rate, that represents the number of megawatt hours generated by non-hydropower renewable energy sources as a function of the number of years since 2007. I want to talk about that phrase as well. And then once we've created that model, we're going to use that model to predict the number of megawatt hours that will be generated in 2017. Now, there's a lot of words in here, and a lot of times students get overwhelmed with the number of words that they see. So it's important for us to realize there's really only a couple pieces of information or data. We're told that there were 105 million megawatt hours of electricity in 2007. And we're told there are 219 million megawatt hours of electricity generated in 2012. Those are going to be my two data points. Then I'm supposed to use those to write a linear model, and then I'm supposed to do it as years since 2007. That phrase is very important. I'm going to come back to that in a second. Once I've created that model, I'm going to use it to predict what happens in the year 2017. So, since I'm talking about years since 2007, it's important for me to realize that 2007 is going to be year 0. I don't know why there's an S there. That's a little typo. A year 0. In the year 2007, it is 0 years since 2007. If year 2007 is year 0, what does that make the year 2012? Well, hopefully you realize that's going to be year 5. It's 5 years after the year 2012. That makes the year 2017 what? Hopefully you realize that's year 10. I got to learn how to punctuate appropriately. I worked so hard to get those exclamation or those quotation marks on, I completely forgot about putting the periods in. So, here's what we're going to do. I'm given a certain relationship. I'm given the number of years since 2007, and I'm given the amount of electricity that was produced that year. This is how I'm going to set up my coordinates. In the year 2007, or year 0, we generated 105 million megawatt hours. So that's going to be the coordinate 0, 105 million. And then in the year 2012, or in year 5, we generate 219 million megawatt hours. These two coordinates can be used to find the slope, since we know it's supposed to grow at a constant rate of change. If I were you, I would pause the video at this point and go ahead and try and calculate that slope before watching me do it. One thing that I would do is I would leave off the million. We're going to stick that on to our final answer. We're just going to deal with the year 0, 105, and the year 5, or the coordinate 5, 219. I use my slope formula. I make sure I write this down every single time. It serves 3 purposes. Number 1, it makes sure that I'm learning it and memorizing it. Number 2, it tells people that are looking at my work what I'm planning to do. And number 3, it helps me to keep my thoughts organized. Those are the 3 reasons for rewriting your formula. I plug in the value specific to this problem. We ended in 219. At 219, we started at 105 million. We ended in year 5. We started at 0. That's 114 over 5, or if you turn that to a decimal, we get 22.8 million megawatt hours of energy produced every year. Now, ordinarily, I do not like to use decimals, but because our numbers are so large here, it's unlikely that I'm going to be graphing this, so I go ahead and I turn it into a decimal. If you wanted to make this 22 and 4/5, you certainly could, or if you wanted to leave it in rise over run form, you could leave it as 114 over 5. Notice that we were given our y-intercept, 0, 105, which means that we can now write our function. This tells me that we're going to generate y amount of electricity in year x. So 22.8 million megawatt hours of energy for every extra year, plus the 105 million when I start. So let's go ahead. The problem says predict what's going to happen in the year 2017 or in year 10. So I plug in year 10. And I get 333, making sure that I put my million megawatt hours onto the end. In 2017, they will generate 333 million megawatt hours of electricity. Hopefully this has been helpful for you. I hope it's very clear for you why we made the year 2007 year 0. Sometimes that's a sticking point for students. Keep in mind that if we did not make the starting point year 0, the year 2007, what would have had to have happened is we would have had to start with the year 2007, 105 million, and the year 2012. Let's see if I can draw that. 2012, 219 million. That's going to give you a really messy slope, and it's going to make your y-intercept something different. This is going to be however much energy was being generated in the year 0. And that really wouldn't make a whole lot of sense, because in year 0, hydroelectric energy, or I should say non-hydroelectric renewable energies really were not very, very common. So we don't really want our pattern to go all the way back to year zero. It's going to be really messy. It's going to give us some really bizarre numbers. That's why we like to set 2007 as our starting point. You can set any year to be your starting point, and you can predict the change from that year. By making 2007 year zero, it gave me my y-intercept right at the beginning. So that also was very, very convenient. Hopefully this has been useful for you. Hopefully you got something out of it. If not, go back, watch portions of it again. It should all fit together as you see it. I know especially this last example can be just a little bit tricky, and we did do it relatively quickly, so it might be worth your time to watch at least that portion over again. As always, we do appreciate you joining us. You guys take care of yourselves, all right? Make sure you smash that like button and ring that bell to turn on your notifications. We'll catch you later. Bye-bye.